So far we completed iteration 1, planning for the project, and we are done with iteration number 2, building the help screen. And our app now has a fully functional help where the user can learn about the game and practice the different sounds of each game. Now we move to iteration number 3, where we're going to build the structure of the game itself. We said that the game will be made out of multiple turns, so the user will start a game, multiple turns will pass, and then the user will respond. And when they are done, it will display to the user end of game. And then each time it will play a random sound. So we can start by playing the random sound, or building the structure of the game, or a combination of the two. So let's see how our analysis will lead us in iteration number 3. If I go to a new page here, and we start with, so this is iteration number 3, and it's the solution formulation. So we're still in the problem. I guess my pen wants to jump through. So problem formulation. And in the problem formulation, we define the scope of this particular iteration, as well as how are we going to test it. So the scope here is that we want to start the game. So the user starts a game. And then I think we'll go with the game plays a random sound. And the user selects an answer, and then the game selects an answer, and the game ends when the turns are over. And the game will respond with a text, and then the game will be over. And how are we going to test this? This is where we probably need to log the note that actually was played. So we'll see which note was played that was selected at random. And so we can see if it's if they are running in random or not, and we'll play a game of 3 turns and see if the game will actually end. So moving to step number 2. Step number 2 is solution formulation. Solution formulation. And we have we'll start with the model. And the model, we still have the file, the sound file. And as we did with the help screen, we'll use the AV audio player to model that file. We also have in order to play a random sound, we're going to have to follow the same mechanism that we did in the project number 1 in displaying a code. So in order to display a random code, we put all the codes in a collection, and then we randomized the index of the collection, and based on that we were able to select a code and play it. So in this case we can do something similar. If we are able to build a collection of all the files that are in the notes, and randomize that index, we can find play a sound at that random index, and that will get us to the actually playing a random note. So we need a collection of all file names, all URLs. So we'll use the NS array for that collection. We also need a counter to count the number of turns. And this will be an integer type. And so this will be the turns, and we're gonna go through them, and it's a collection, and it's an audio player. I think that might be all what we need here as a model, and if there's something else, we'll discover it as we go through the process. So in the view, I already have the view from the layout that we created, or the wireframe or the mockup that we created. So to sketch that, we have the help screen here, and we have the stats. So we'll add a button to start the game, and we add multiple buttons for each one of the notes, and we'll add a label here to display the answer to the user. In the next iteration, we'll add an image and display that image, and we'll add a turn counter here as well. So in the view, we'll use a UI button for the start of the game. We use UI button to represent the notes, and this is kind of similar to the help screen, but this time when the user click on a button, it's not gonna play the sound, but it's gonna evaluate whether the text on the button is the same as the file name that actually was playing. So we'll use that, and then the label will display if it is correct or incorrect answer. And we're gonna see how we can implement that when we get to the controller. So in the controller, we notice here that we have multiple events. First, we have the start game. So the user will click a button to signify the beginning of the game, which then needs to reset the counter and reset the label, because we're starting a new game. When you start the game and then you play a random sound, yeah, that's correct, play random sound, and then wait for the user to tell you if it is, wait for the user to make a selection of what they think that sound is, and that then leads us to the second event. The second event is when the user selects, or user input. What happened here is that user will click on one of the notes buttons. When the user do that, we need to know which button the user selected, so we will need to retrieve the name of the note that similar to what we did in the help screen. And since it only has A, we need to append to it the MP3. Then we need to compare with the note that was played. So it seems like we need to find a way to model the actual note. So I'll come back here to the model. And add something here that will be the note. And we can save the note as a string, and we'll save it as the like in the format a.mp3, so the actual file name and the extension, and we'll save the note like that. So this will be the current note, the note that's actually being played. So because we're gonna need to compare what's on the actual button that the user clicked with what's being played. So we're going to need to know what's being played and give it that model. So once we make the comparison, then we update the label. And then play another note, another random note. All right. So when you say play another random note, should the app needs to play that random note on its own, because the user already started the game, so the game is running on its own until the number of turns have ended. So here you notice there is playing random note, random sound, and then in the second event also wants to play another random sound. What this then suggests to you, there is one function that needs to be used in two different events, so we can separate that as its own function. So we can, although this function play note or play game, although this function is not going to be called by a user event, it's going to be called from the start game, and it will be called again from the user select, from the comparison when the user select the answer. So the play game, what it needs to do is it needs to check if the maximum turns is reached. So it needs first to update the counter and then check if the maximum turns number of turns is reached. If it is not reached, meaning that we still have more turns, then it needs to get a random number between 0 and the number of files, and we can get that from the collection. Then it needs to retrieve a URL from the collection of notes. And to remind you, we modeled all the notes here as a collection, but we didn't load it, so you're correct. So in addition to those, we need to also model the viewDidLoad event. And in the viewDidLoad, we need to load the URLs in an array. So we'll return the URL for the collection and play the note. However, but if the is not reached, if it is reached, which is if we use, like this is the comparison, if we do the if statement, then the else statement will be end game, that the game will end. So there are 4 events that are contributing to this play game. Start, when the user will initiate that event, the evaluate, the user response, and the user will initiate that, and then the play game, which will be initiated from either of the previous ones, and then the viewDidLoad, which will be initiated from by the app itself when it is loading. So in the implementation, step number 3, so in the solution implementation, we can organize it per each one of those. So first we need to build the view, which means we need to add the start button and add the note buttons and add the label. And then we need to connect the UI components as outlets, the label, and as actions for the buttons and the start button. After we do that, in the viewDidLoad, we need to initialize the collection. And then in the start game, we need to reset the counter and start and the play game. And in the play game, we need to play a random note. Then finally, in the evaluate or check answer, we need to determine if answer is correct or not. So multiple steps here, and we're probably going to need to do testing at each one of them. Testing at each one of those steps to make sure that it is working, as well as a final testing here at the end for the full game. So that's what we're going to do. I'm going to stop here, and in the next video we'll go through the implementation.